the last part of chapter 1, which is electromagnetic spectrum. So to have a look like what is electromagnetic spectrum, you're gonna have to see this picture here. So this is what we call an electromagnetic spectrum. So electromagnetic spectrum is just basically waves. Okay, so, and we call it an electromagnetic spectrum because it is produced from an electric field and magnetic field that is perpendicular to each other. So their vibrations or their energy that keeps on being perpendicular to each other or at a certain angle will cause them to have an energy, and therefore they travel in a form of a transverse wave like this. So one information that you need to remember about electromagnetic spectrum is that they all travel at the same speed, which is the speed of light. So their speed is c, which is speed of light, and then the value will be 3 times 10 to the power of 8 meter per second. So if you can see here in this picture here, so the first part here is showing this red color line is showing you the wavelength of this electromagnetic spectrum. And on the first part here on the left, for radio wave and also microwave, they have a large wavelength. But when we talked about large wavelength, it's not just an ordinary like large wavelength. It is a really, really large wavelength. So like for example, the value below here is showing you like how large these wavelengths are. So like for radio wave, it is up to 10 to the power of 3 meter wavelength. That is like kilometer regions. So the size could go up until the size of a building, right? So that is just for one wavelength. Like for this, it's like kilometer length. Okay, that's how large it is. The smallest that the size of a microwave can go is in the centimeter region, which is 10 to the power of negative 2 meter, right? When we talk about infrared, then the size is becoming much more smaller, up to the point of a needle, which is 10 to the power of negative 5 meter, right? And then visible light is somewhere in the micrometer region. Ultraviolet light to X-ray is somewhere in the nanometer region. So if you compare it to a size of things that you know, then it will be like the size of a microorganism. So for ultraviolet, it's like the size of a molecules. X-ray, the size of one wavelength, okay, one wavelength is the size of an atom. And for gamma ray, it's like the nucleus of an atom. So that's how small it is, because 10 to the power of negative 12. Okay, so that is in terms of their sizes or their wavelength. So if you can see as well, moving from left to right, then the wavelength become much smaller. So because wavelength is inversely proportional to frequency, so frequency increase as you move from left to right in the electromagnetic spectrum. And frequency, you always relate them to energy. So when frequency increase, that means energy also increase. So out of all of this wave in the electromagnetic spectrum, then that means that the radio wave here have the less energy, okay? And gamma ray here have the most energy. So in other words, the radio wave is the less harmful and the gamma ray is the most harmful because they have a lot of energy. They can ionize stuff and things. They can do things. Yeah. They can even alter and mutate cells, right? So the last part here is the temperature, but this is not really important for your syllabus. All right, so let's look at a summary of what we've looked at in the electromagnetic spectrum. So moving from left to right of this electromagnetic spectrum, the wavelength will decrease, frequency increase, and energy increase too. Okay, so now we're going to move on to one by one of each of this wave in the electromagnetic spectrum. So the first one, we're going to look at the most left first, which is the radio wave. So radio wave is used for broadcasting and also telecommunication. But mostly we use this as ground waves, meaning that you won't need to use satellites for it because it is so large. So it can just pass through building, it can just pass through mountains. It can be diffracted off mountain. It can be reflected off of a mountain or a building. So you don't really need anything else to actually transmit it. You just let it go and then it will just like it will just move all around the world. So basically, like over here, then it will move like all around the world, and just like that. So that's how you actually broadcast a radio communications. Okay, and however, although it is the least harmful radiation in the electromagnetic spectrum, if you are able to absorb like a large enough amount of this radio frequency wave, then the worst that can happen to you is that you could get a lot of heat from it. So out of all this heat, then you might get skin burn, or you might get tissue damage. So that will be like the detrimental effects of radio wave. But mostly it's the safest out of all of the wave in the electromagnetic spectrum. Okay. Microwave. So microwave have the ability to penetrate through the atmosphere. So mostly we will use this for satellites communication. But you also know microwave as microwave, okay, which is the oven that you use to heat up food, right? Okay, so in terms of communication, they are large wavelength because it's able to penetrate to atmosphere. So you can use one satellite, bring the signal to Earth, then those signal can be reflected, diffracted of hill and mountains throughout the whole world as well, throughout the Earth, right? In terms of microwave heating, so what microwave do is that they will penetrate into the food and attack its source, which is the water. So what microwave did is that heat up the water, all of the dipoles of the water in the food. So if you put in food that have water in it, like meat, yeah. So then it will be heated up. Okay, but if you put food that just have like air pockets in it, like bread, for example, then it will just turn hard like stone, like when you take it out of a microwave, because there's no water for the microwave to heat up. Okay, so yeah, that's it. And it's also in the safe region of the electromagnetic spectrum. So that means that if you are exposed to a very high amount of microwave only, then you will get an effect such as burn and cause skin burn mostly, right? Okay, infrared. So infrared have various applications. Infrared is just basically what we call heat. Okay, so you got heat from the sun, you got heat from almost everywhere. Okay, and a lot of this application here is actually detection of heat signature. So heater is not heater gives out heat, you know, because then gives out infrared radiation. You give out infrared radiation because your body is hot, right? Okay, so like night vision equipment, you just put in you just place basically a heat detector, okay, into a goggle, then you use it. So at night, then you will see heat signature like wherever you go. And also for crops view, this will be placed on a helicopter, okay, and you will go through forest area and capture the infrared picture of the crops. So if the crop reflect a lot of near infrared light, so they will appear to a certain color, usually red, okay, then that means that those leaves are healthy. But if they don't reflect of a lot of near infrared wavelength, when you capture it using this infrared camera, right, then that means that the leaf may be lack in nutrition, maybe not as healthy as it used to be. And if the reflection of red light, blue, green, and also near infrared wavelength is just the same, then that means that the leaf is dead. Okay, and then you also use it for remote control. You also use it as intruder alarm, because also heat sensor, like basically, so when your alarm, when you detect like there are heat signature in the house, then the alarm start to make a sound. Okay, and this picture here is a rescue mission. So you won't usually use it that much for when it's a fire, because when there are fire everywhere, there are heat everywhere, right? So it's really hard for you to really view where the survivors are. But mostly in situation like hostage situation, then you might be able to use infrared camera, because then you'll be able to see those with the gun and those who are like tied up. Okay, so then you know who's the terrorists and who's actually the victims. All right, and the detrimental effects of heat, because it's infrared, right? Then you will get skin burn, right? And the next one here, we've got visible light. So any photography, camera, human eye, optical fiber, anything that uses, yeah, that involves you looking at it, then it will be visible light, because it's the only spectrum of light that we human can actually see. So this picture here is camera, and this is optical fiber. So the thing is, if you expose too much to lights, what it can do to you, its effect is that it will speed up the rate of your premature skin, meaning that you get older. Like your skin will get older, like pretty quickly, will start to dry and start to become old. Okay, and if you exposed to too much of lights as well, then in the end there's a possibility for you to get skin cancer. So that's why at night when you sleep, you should turn off the lights. All right, so to reduce the amount of light that you receive daily. Okay, so that's it for visible light. And then ultraviolet. So ultraviolet light, other than the fluorescent lamp that we normally use, mostly its application is to actually check for fraud document. So this include passport, money, and so on. Okay, so this picture here is the two type of lamp that you use to detect a fraud document, to detect like passport. So some of the material in the lamp will be able to absorb fluorescent light, so or ultraviolet light, sorry. So that's why it will be able to see the signature that you put into the document. And this picture here is a real 50 euro money. Okay. And then next one is X-ray. So X-ray is very popular because all of you, I'm sure, have done this. For medical imaging and also for security imaging, like baggage checking at airports. All right. So how this work is that X-ray have very high energy, so they will be able to penetrate your skin and also your flesh. Right. So if a human like stand here in this picture, okay, and they have bones inside, so basically all the X-ray that shines onto him can pass through him, except for the denser part of his body, which is his bones. So all of the stuff that pass through means the area where there's no bone will hit the screen here, will hit the screen like this, and the area that have bone will not be hit. That's why in the picture here, then you see this is a white color, bright color, and here the other area is darker color. So this darker color is the parts where X-ray hit the film, right? And this area here is where the X-ray is not able to hit the film. And it also depends on the density of the bone as well. So the bone that is not as hard as this bone, for instance, then there are still some of X-ray that can pass through it, but at a slower rate. So the amount of X-ray that hit the background will be lesser than the amount of those that hit the background, like over here, for instance. So that's how they do it. Same goes for baggage checking as well. So if the materials inside the bags are made up of hard metal or heavy metal, not heavy metal band, heavy metal, okay, then the X-ray won't be able to pass through it. And then you can see in the picture here, they got guns in their bags, right? Or any other harmful material that is not allowed on flights. All right, and then the last one is gamma ray. So gamma ray have the highest energy in the electromagnetic spectrum. And so it can be used to actually kill cell. So when you try to treat cancer, chemotherapy, so what you do is you shine this gamma ray to a targeted cell part so that it will kill off the cell. But the problem is, not only it will kill the cancer cell, it will basically kill all the cells nearby. And that is why you don't irradiate this gamma ray at a huge huge amount of ray at one time, and it need to be done multiple times so that it will give time for the healthy cell, this pink color here, to actually heal before you actually try to kill the cancer cell again, right? And then for sterilization, this picture here, so you've got an irradiation of gamma ray in this stuff, okay? So when you put it in, you close it, and then the gamma ray will be radiate into it, and all of the bacteria will be killed and sterilized, and you can use it. It will be free of bacteria and viruses, right? So the detrimental effect is, of course, it can create cell mutations, and it also can lead to cancer as well if you're exposed to it, if you're exposed a lot into it, okay? So because they can really, really penetrate your skin and stuff, right? So that's it for all of the items in the electromagnetic spectrum. So now let's have a look at a past SPM question. So what you can do now is pause the video, try out this question, and come back later for the answer. Okay, so when you answer question, you have to read the question. Okay, so don't just read A, read the whole thing here too, because if you don't read the whole thing here, then you might get the wrong answer. Okay, let me show you why. Okay, so this question says that diagram 6 shows a group of electromagnetic wave KLM and O arranged according to their frequency and wavelength. So the energy of the wave is increasing from the left to the right, and the wave propagates at the same speed in a vacuum. So when they said this already in the question, then all of the info that they already give you in the question should not be in your answer. So when question A asks you, state the type of wave shown in diagram 6, do not answer electromagnetic wave, because it's already written here. It's already been told to you. So other than that, the type of wave that you can see here, your answer should be transverse wave. And then they talked about the energy increasing from the left to the right. So when the question talked about the changes that happen from the left to the right in terms of frequency and wavelength, so you can talk about it, because they don't talk about the changes in frequency and wavelength in the questions, in the part of the information of the question there, right? Okay, so as we're moving from left to the right, the frequency increases and the wavelength decreases. Relationship between frequency and wavelength, you should know this. It's already, I've shown you many times in all the previous videos as well. So it's inversely proportional. You can also write it as the frequency increase, wavelength decrease, or as wavelength decrease, frequency increase. So any way around it, okay, is fine. Question D, give two phenomena that can be displayed by all types of waves shown in diagram 6. So they are all waves. So all of the phenomena that wave experience, then electromagnetic spectrum can experience. Example of your answer should be all of the phenomena that you have learned in SPM syllabus, which is reflection, refraction, diffraction, interference, superposition. So 2 out of these 5 will be accepted. And then E, radiation of which wave can possibly cause cancer. So usually your answer will be like the strongest energy here, which is O. You can write wave O. Or you can also write microwave. But if you answer N, or if you answer X-ray, then it's correct too, because it could do in the long term give you cancer. Okay. So based on diagram 6, complete the following. The first one, which one is used to detect counterfeit money? So of course it's ultraviolet light. So you can write M, or you can just write ultraviolet light. And satellite communications is of course microwave. So you can write K, or you can write microwave. There you go. That's the answer for the question. And now for the summary. Okay, so as a summary, you've learned in terms of how frequency and wavelength change as they went through the electromagnetic spectrum. Also learn that all of these waves in the electromagnetic spectrum travel at the same speed, which is the speed of light. And you've also learned the application of each of the wave in the electromagnetic spectrum. Finally, you also learn the detrimental effects of each of the wave in the electromagnetic spectrum. Then that's it for today. Thank you for watching.